interest rate risk and the investment horizon. Short-term investors are concerned with the impact on the flat price given a sudden change in YTM. Now, you might wonder why we are only looking at flat price over here. If you think about it, the full price is equal to the accrued interest plus the flat price. And the accrued interest is simply a prorated number. If this represents a given period from 0 to t and you have a coupon payment, let's say of 10, the accrued interest is simply the fraction of time that has passed between 0 and big T multiplied by the coupon payment. Note that this number is not impacted by changes in YTM. The flat price, however, is, and that is why short-term investors are only concerned with the impact on the flat price. Long-term investors are also concerned with the reinvestment of coupon interest. With long-term investors, there are going to be several coupon payments that they will receive, and those payments will be reinvested. So clearly, long-term investors worry about the rate at which these coupon payments will be reinvested. In section 4.1, we focus on short-term investors and the impact of yield volatility. First, let us make sure we understand this term yield volatility. Yield volatility refers to the volatility of a bond's YTM. The way you can think about this is, if over time we plot the YTM of a given bond, if this is flat, then we would say that the yield volatility is 0 or close to 0. If the yield to maturity is moving up and down quite a bit, then we say that the yield volatility is high. Here I have a simple question for you. Let's say that you are looking at a price versus time graph and you have a zero coupon bond which is following a constant yield trajectory. So the price is increasing from, let's say, 85 to par value, and you are told that this is the constant yield trajectory. What is the yield volatility? The answer is that the yield volatility is 0 because this is the constant yield trajectory. And the reason I'm illustrating this is just because the price is changing doesn't mean that the yield to maturity is changing. Next point, typically short-term bonds have greater yield volatility than longer-term bonds. The reason is that shorter-term bonds tend to be impacted more by monetary policy. If the central bank changes the money supply or changes interest rates, that will have a direct impact on short-term bonds. Long-term bonds are influenced by expectations about inflation, about the general economic outlook. So long-term bonds are less impacted by the monetary policy of the central bank. That's all you really need to know over here. This material is covered in more detail in economics. Now the question is, why are we concerned about yield volatility? The answer is that overall interest rate risk or changes in bond price depend on the duration measure, such as the price value of a basis point, and on the change in yield. So if the yield volatility is high for a given bond or set of bonds, then clearly the interest rate risk is greater. And let me just put down the equation here that you should remember. The percentage change in value of a bond is given by this expression, minus modified duration into the change in yield plus the convexity adjustment, which also depends on the change in yield. So if you have two bonds with the same duration and convexity, but the change in yield is different for the two bonds, notice that the change in value of the bond will be greater when the change in yield is more. In other words, when the yield volatility is higher, the change in price or change in value will be greater and there will be more interest rate risk. This will be illustrated in an example on the next slide. A final point that I want to make here is about parallel and non-parallel shifts in the yield curve. I have alluded to this before. If you have a yield curve where we have different maturities on the x-axis and yield on the y-axis, a parallel shift would be that the yield increases or decreases by the same amount across different maturities. But this doesn't always happen. What you might have at times is that the yield changes differently depending on the maturity. If we have a situation where long-term yields are not changing too much, but short-term yields are changing more, then you will have a non-parallel shift in the yield curve. And this is something that we will see in the next example, which is right here, example 15. Read through this and try it before looking at the solution. All you need to do is utilize the formula that we just talked about, which is this formula for all three bonds. Notice that the duration is different, and presumably here you can tell that bond C has the highest maturity because it has the highest duration, but that isn't really needed. Also, the change in yield is different across the three bonds. As I mentioned, C is probably the longer term bond and this has a low change in yield. A has the highest change in yield, but the duration for C is the highest. So let us see where there is a greater impact. When you plug into the formula that we just talked about, here is what you get. For bond A, we get minus 0.00926. For bond B, we get minus 0.008669. And for bond C, we get minus 0.0123. So where is the greatest impact? Bond C has the highest impact. This number in absolute terms is bigger than the other two. And what this is saying is that given this change in yield, even though the change in yield is less compared to the other two bonds, but the duration and convexity numbers are high enough that the impact is greater. The point to emphasize here is that the change in price of the bond depends on all these three variables: the modified duration, the convexity, and the change in yield. Investment horizon, Macaulay duration, and interest rate risk. As I mentioned before, with longer term horizons, we as investors are concerned with price risk and reinvestment risk. And to understand this concept, we will go back to the examples that we discussed at the start of this reading. We had a 10-year 8% annual coupon bond priced at 85.50, yield to maturity 10.40. What we'll do is consider different investment horizons. Let's take a 10-year horizon. Here, the major concern was reinvestment risk. And the way you can think about it is as follows. A change in interest rate will cause a change in price and a change in reinvestment income. If interest rates go down, then the price will go up, but the reinvestment income will go down. If our horizon is long, then this effect will dominate and the overall impact will be negative. On the other hand, if interest rates go up, then price will go down, reinvestment income will go up, but again, the reinvestment income will go up by a larger amount. So the common theme is that With longer term horizons, the reinvestment income dominates, so investors will be better off if interest rates go up. What if the investment horizon is relatively short? Then the price effect dominates. A decrease in interest rate will mean that the price goes up more so than the decrease in reinvestment income. So with shorter term horizons, the investors would prefer a decrease in interest rate. So there is going to be some middle ground, an investment horizon where the two effects, the effect on price and the effect on reinvestment income, balance each other out. And that in between number, or that in between investment horizon period, is 7 years. I'll skip all the detailed calculation because the key here is to understand the point. We have a 7-year horizon and the same 10-year bond. This is data that is already given. At 10.4%, the future value of reinvested coupon is this. This is the sale price, total return, and horizon yield for a 7-year horizon. All this is for a 7-year horizon. I hope you're not confused between horizon and maturity of the bond. The overall maturity of the bond is 10 years, but here the investor is holding the bond for a 7-year period. And this is material that you have seen in earlier examples. So with a 7-year horizon, the horizon yield is 10.4%. What if there is a decrease in interest rates? Interest rate is down, so that has a positive impact on the sale price. Notice the sale price of 96.48 would be higher than 94.07. So that is a positive. But what about the reinvestment income, or the future value of reinvested coupon? That number is lower than what we would have if the yield stays constant. Overall though, these two differences cancel each other out and the total return is almost the same as the total return if interest rates were to stay at 10.4%. What if rates go up to 11.4? Then again notice that the future value of reinvested coupon and sale price change, but they offset each other and the total return is still roughly the same. In other words, whether interest rates go up or down, the horizon yield or the 7-year yield remains approximately 10.4%. And this actually is another interpretation of Macaulay duration. Macaulay duration indicates the investment horizon for which coupon reinvestment risk and market price offset each other. But there is an important simplifying assumption we make here, which is that there is only a one-time parallel shift in the yield curve. In other words, the yield is changing by the same amount across different maturity periods. So to summarize what we are talking about, and I think this is important from an exam perspective, if the Macaulay duration is less than the investment horizon, so if our Macaulay duration is 7 and investment horizon is 10 years, then the coupon reinvestment risk dominates. So here an increase in interest rate would be good for the investor. When investment horizon is equal to Macaulay duration, so 7 is equal to 7 in our example, then the coupon reinvestment risk and the market price risk offset each other. And finally, if the Macaulay duration is greater than the investment horizon, then the market price risk dominates. So investors here will actually be happy with lower interest rates. A term that you should also know is duration gap, which is simply the difference between the Macaulay duration and the investment horizon. Now let's take a look at example 16, and I want you to do this first before looking at the solution. This is a good question because it tests several concepts. The first part is tedious but mechanical. This is something you've done before. We need to calculate the approximate Macaulay duration using a 1 basis point increase and decrease in the yield. If you recall, this method where we have a 1 basis point increase or decrease is used to calculate the modified duration. So we first come up with the modified duration using techniques that we have employed in several times in this reading. That would be 7.5361. So this is the modified duration. But we need Macaulay. So recall the relationship between modified duration and Macaulay duration. We said that modified duration is equal to Macaulay duration divided by 1 plus R, where R is the 1 period interest rate. Here we have an annual bond and the interest rate is 8%. So the Macaulay duration is going to be the modified duration multiplied by 1 plus R. That would be 7.5361 multiplied by 1.08, and this gives us 8.14. What is the interpretation of this number? The interpretation is that if the investment horizon is 8.14 years, then the price risk and the reinvestment risk offset each other. So remember that fact. Part 2 then says calculate the duration gap. And as we saw on the previous slide, duration gap is Macaulay duration 8.14 minus the investment horizon, which is 10 years. So this is approximately 1.86 negative. What does a negative duration gap mean? It simply means that the investment horizon is larger than the Macaulay duration. And again, recall from the previous slide that when the investment horizon is greater than the Macaulay duration, then an investor is more concerned about reinvestment risk. And the concern, therefore, would be that interest rates will come down. With lower interest rates, the impact on reinvestment income is going to be greater than the positive effect on price. So the investor is going to be concerned about interest rates coming down. That is the risk.